Hello everyone. WinDump is the Windows version of TcpDump, the command line network analyzer for Unix. WinDump is fully compatible with TcpDump and can be used to watch, diagnose, and save to disk network traffic according to various complex rules. So in this video we will talk about TcpDump. Firstly, what is TcpDump? TcpDump is the most powerful and widely used command line package sniffer or package analyzer to which is used to capture or filter TCP IP packets that are received or transferred over a network on a specific interface. It is available under most of Linux Unix-based operating systems. TcpDump also gives us an option to save captured packets in a file for future analysis. Each saved file in PSAP format that can be viewed by TcpDump command or an open source GUI-based tool called Wireshark that read TcpDump PSAP format files. TcpDump is a free and open-source wireless data network packet analyzer that works on the command line interface. It is the most commonly used CLI tool to analyze network traffic. TcpDump allows users to see, read, or capture network traffic transmitted over a network attached to the computer. It is useful in system administration, monitoring network traffic. Originally, it was written in 1988 by four network research groups: Van Jacobson, Sally Field, Vin Paxson, and Stephen McCann. Berkeley works at Lawrence Berkeley Laboratory in California. It was organized 11 years later by Michael Richardson and Billy Feiner in 1999, who, who created the TcpDump site. TcpDump works on all Unix-like operating systems. The Windows version of TcpDump is called WinDump and uses WinPsap, the Windows alternative for libsap. This video is a look at using TcpDump for capturing and analyzing packets on network interfaces. It will talk how to use TcpDump by an example on a daemon virtual machine. The topics covered will include starting captures, understanding the capture display output, saving captures to a file, reading from existing captures file, using filter expression to isolate traffic for capture or for display and changing display. Before we jump in, a quick definition: TcpDump is utility used to capture and analyze packets on network interfaces. Details about these packets can either be displayed or to the screen, or they can be saved to a file for later analysis. So let's jump right in and start using it. Version checking. Assuming TcpDump is installed, version information can be obtained with tcpdump-h. On this system, we can see the TcpDump version is 4.9.3 and the libcap version is 1.9.1. Running TcpDump. The first thing to note is TcpDump requires super user prevalence. Therefore, in this video, all commands are prefaced with sudo keywords. To run TcpDump, the available interfaces for packets captures need to be determined. If these are not already known, they can be checked with tcpdump-d. On this VM, eth0, eth1, any and the loopback interfaces are available. The any option is the sudo interface that can display packets from all interfaces. Let's capture packets on all interfaces by using the any option. Now we see packets are moving too fast to read. TcpDump will not stop without any interrupted signal. So to stop the capture, I will use Ctrl plus C. Instead of letting TcpDump run until interrupted, you can use the lowercase c option. This option instructs the utility to stop after the specific number of packets. In the output, we can see host names are being used instead of IP address. Also, commonly known ports are replaced with application names. Usually, however, it is easier to work with IP address and port numbers instead of these names. The lowercase n option will take care of this. Now the output shows IP address and port number. When TcpDump is run without touch an option, the utility will trigger reverse or PTR DNS looks up to find host name for IP address. As it captures them, this is good to keep it in mind. To realize TcpDump is itself triggering DNS traffic as it captures if the end option is not used. Capture packet size, and the second line you can see it says capture size is 262.144 bits. This means that for every packet TcpDump will keep 262.000 bits for analysis. This is much longer than the typical packet size, so essentially this is saying TcpDump is capturing full packets. It's important to note the default capture size. Some versions of TcpDump default much smaller capture size, for example 96 bits. This would mean just the first 96 bits for every packet is capturing and the rest is thrown away. The capture size can be alternate with the lowercase s option. Here you can see I've requested just a 96-bit for each packet instead of the default I had of 26200 specifying 0 with the dash C. Option means maximum size or 26200 as was seen in the default. When performing captures, it's important to think about the goal when deciding the packet size to set. For example, if you are just looking for evidence of lost or out of order packets on a longer file transfer, you probably don't need much more than 64 or 96 bits of each packet. Alternatively, if you are troubleshooting problems at the application layer, you may require having full packets. TcpDump output. Here is a look at the files displayed in the TcpDump output. For some TCP packets, first there is a timestamp for in the libcap picked up the packets on this virtual machine. We can see values down to milliseconds and even to microseconds. Next, the protocol is specified. After this, the source IP of the packet, a dot, and then the source port of the packet. After the source IP in port is the destination IP in port. These addresses are followed by TCP flags, which could be send, act, rest, fin, urgent, and push. The next fields are the sequence and the acknowledgement numbers. TcpDump by default uses relative numbers. Here let's look at an example because I will cover that later. This capture just looking at one direction of traffic on one TCP session. In the first captured packet, the real sequence numbers are displayed. These long numbers. After that first packet, TcpDump switches over to showing relative sequence numbers because they are easier to track. So here in the second packet was tree of a sequence number of 196. Incidentally, relative sequence numbers can be turned off the uppercase S option. After the sequence and analogous number is the receive window size. Here we can see window size of 333. However, this is actually not the real receive Windows because Windows scaling is enabled. To be able to see that Windows scaling is enabled, you need to go back to the three-way hand check. This is where the Windows scaling option will be not noted. Great. So here is capture on port 53 DNS. Of course, uses UDP port 53. Now I will do a double. You get to youtube.com. To generate some DNS traffic in the capture display, we can see the demo VM made two requests back to back, first in the record query, which is IPv4 query for youtube.com. After that is a query in for youtube.com, so this is for IPv6. Next, there are the response for the query. There is R11 EPS returned back from EAAA DNS servers for IPv6. One record come back in the response after this is some interesting activity. Save captures to a file for later analysis. This is done using the lowercase W option. Now the capture is being written to the file captured pickup and issue. There is no indication of how many packets are being written or if any at all are being captured. So when writing packets to a file, the lowercase v option is very helpful. Now we can see the numbers of packets captured. Again, TcpDump will continue to run until interrupted when writing to a file and capturing a high traffic interfaces. The file can be grow quite longer very fast. This can pose a problem on a system which lacks sufficient storage space. A good way to limit the file size is to use the lowercase c option. Here the capture will write to the file captured pickup, but it will stop after 20 packets. Reading capture files. Existing capture files can be read with that our option. The same output scenes as when packets when display stored to the screen. Again pack is go by too quickly on large files, so I will use a pipe and list, and that help me so I can scroll up and down throughout the capture. TCP-dump filter expression. The use of filters is important when using TCP-dump, especially when working with very long capture files. Filter let you log in on just type of traffic you are interested in and ignore the rest. So let's see some examples. Host keyword with the capture. I'm using the host keyword to specify that I only want to capture traffic going to or from the IP. The source and the destination keywords. This is the same capture as before, expect that now you add the source keywords src destination. Here an example of a compound expression. Port 80 or port 443 traffic is shown but only for the address 192.168 at 191 at the source or destination. Note the parentheses around the port numbers. These are important to include both ports as part of the understandment. Here, if they were not used, I would not get the intended result. Filters can be used to include or ignore an enter submit. Here is a filter are used to look for traffic heading towards public internet EPS. The source of this traffic should be from the network 192.168.0.0 with /16 submit mask. I'm using the net keyword to accomplish this. Also, the destination network should not be local. Filters can be applied based on MAC address, as well using the inter-host keywords. This capture is redirected to traffic shower from this MAC address. In the capture's output, MAC addresses aren't visible by default, so to see MAC address and captures we use the lowercase e option. Adjusting TcpDump output. TcpDump has some option to adjust the output scenes. When looking at capture data, the XX option displays more details about packets. Here we can see the HTTP GET as asking. Often the hex is actually not needed, so the A option can be used instead. The V option is used to provide more details, and the packet captures. Touch VV and Touch VVV will provide increasing levels of details respectively. When displaying more verbosity on my VM, TcpDump display an error indicating there is a checksum error. This message is usually because the system has checksum offloading enabled, and at the point at which pickup grabs packets, the correct checksum hasn't yet been inserted. This error can be ignored by using the uppercase K option. One last option I will look at here is the timestamp display option, which uses lowercase t. Depending on how many t's are used, this changes. This displays, for example, 1t removes timestamps completely.
And now we're gonna pass to the traffic capturing on Windows using the WinDump. WinDump is the Windows version of the TcpDump, and it's fully compatible with it, and it can be used to watch, diagnose, and save to disk network traffic according to various complex rules. WinDump captures using the WinPcap library and drivers, which are freely downloadable from the windows.org website, and it can run under many Windows versions starting from the Windows 95. As we said, the WinDump using the WinPcap libraries and the drivers. So to use the WinDump, we need first to install the WinPcap from the website winpcap.org. We'll find the link in the description. We go to WinPcap and get WinPcap, then installer for Windows. We go back to WinDump, get a WinDump, and download. Now we install the WinPcap. Then the WinDump. Now, first thing we do, we go to the command prompt and go to the C drive. And go look and see if we can see the WinDump on the C drive. I still don't have it, so I have to copy it on the, I go to the download file and copy it in the C drive. And now we can see the WinDump.ex in the disk local. To launch a WinDump in the command prompt, we just write WinDump. Here we'll capture the packets on all available interfaces. To stop it, we use the Control C, and to clear it, we use the CLS. Now, let's say that we want to display the list of available interfaces that it's associated with my machine. And to do that, we use the command WinDump space minus D, and this is the interfaces that it's connected with my machine, as you can see. And now let's say if you want to capture packets on one particular interface, let's say if you had more than one interface, but you want to capture only on a particular one instead of all of them all. To run this command, we need this WinDump space minus I and the number of the interface. Let's try 1. And we'll give you the capturing of only the first or the interface number 1. Use the Control C to stop it. Let's try the same command but this with another interface. For example, 5. There is no packets in this interface. Let's try number 3. And we use Control C to stop the capturing of the packet. We can also try the same command, but with the specifying about the port number, like we use the same command WinDump space minus A and the number of the interface, and we can add port and the number of the port. Now let's see if I want to capture the entire packets and write them in a file and then to read them later or whatever. We use the command WinDump space minus A space the number of the interface that I want to use, then space W and the file. As you can see, I create the file names was win capture win capture, then a file. Let's wait to traffic capturing. Ctrl C to stop it. As you can see, 22 packets was captured and 0 packets were dropped by the kernel. Let's see. this is all the packet capturing that we had. Let's say we want to capture all the packets and they're entirely using the SAP-SNAP is equals 0 options and logs the output of the file of analysis on Wireshark. We're gonna use the same command that we used WinDump space -I space the specifying of the interface number, then space that we put the file and test 3. Let's wait for the traffic. As you can see, there's the file test 3 on the win capture file. Stop it with the Ctrl C and go to Wireshark and import the file. And there we have